Hey everybody, this is Mr. Taylor. So what I want to do today is introduce you to Unit 5, 8.4b as we get into proportional relationship, interpreting the unit rate as slope of a line, and then model this particular relationship. And we've already really got to look at slope. We've got to look at how to find it using rise over run. We've got to look at how to find it using the slope formula. So now we just want to go just a little bit further and compare and distinguish between a unit rate, slope, and the linear proportional relationship between the two. Well, 8.4b tells us that we need to look at unit rate as being a ratio between two different units, where one of the terms is 1. Now, I would probably say that what they're saying is if we look at this, then we're talking about maybe 1 over 4, or let's just say $1 to let's see, let's do this again, maybe $1 to 4/4. That's what we call a unit rate, or we could say 4/4 to $1. So that's what the author means when he says a ratio between two different units where one of the terms is 1. Now, slope, on the other hand, we talk about the steepness of a line. The rate of change in y, which is your vertical component, and compared to the change in x, which is your horizontal component. We also note that this is the same as rise over run. So we're saying that if we have a particular graph that's running through the origin, and we will take a point here, and if we're looking for a point here, we would rise up so far and run so far. Now notice this rise and run can mean that we can go down and over as well. So down and to the left would give us a positive slope, as well as up and to the right would give us a positive slope. The issue is not really of whether the slope is positive or negative, just really trying to show you the elements of rise over run. We also talked about that. Well, you know what I like to do before we get any further with this steepness. Let's talk about that. So if that's all possible, and now listen, I'm gonna try this eraser again. There we go. Now I didn't make all that noise I did the first time. All right. So if we look at steepness, now if I had a slope with a, let's say 1/4. Now that slope has a rise over run of 1/4. If you notice, this slope is closer to the x-axis than it is to the y-axis. So the steepness is not that great. Okay? But what about if I had a slope and the slope was 5? Now, this particular slope is closer to the y-axis and further away from the x-axis. So a slope of 5 will have greater steepness than a slope of 1/4. And it does that with slope. The higher m, the larger m value is, the closer it is to the y-axis. So that's what we mean when we say steepness. Just want to make sure we clear that up for you. Now, moving right along, let's talk about, and then really this video is just really on giving you definitions and a background on the subject, and not necessarily a lot of work. We'll get to the work in the next video. Let's talk about the change in x and change in y and the change in x. So we know that this is the slope formula, which tells us that the second value of y minus the first value of y is equal to this divided by the second value of x minus the first value of x. And if you have two ordered pairs, let's just say 6 comma 2 and 3 comma 1, just using something really simple. And then when you're looking at slope, you're just going to input this. Now here are my x and y1, and then here I have my x and y2. So I'm going to just substitute in. So I would have here 1 minus 2 divided by 3 minus 6. So this is because we know this is how we use slope. And then, of course, this is 1 plus a negative 2, which is going to give us a negative 1. So, and then here we have 3 plus a negative 6, which will give us a negative 3. A negative and a negative will correspond to just a positive. So you notice here we have what, 1 over 3. So we go back to that unit rate where it says a ratio between two different units where one term is 1. So our slope in this case is a positive 1/3. So just a little review showing you how you use it. And you notice the author also says right here that M, when we're looking at the slope intercept form of a line y equals mx plus b, that M is going to always be your slope, which I tell you guys all the time, that's just that coefficient in front of x when you have it simplified in that form. Okay, so moving right along. So now we want to just briefly look at let's just briefly look at the linear proportional relationship. So linear, when we talk about linear, we're talking about a straight line. A line that's going up, we say is positive. A line that is going down and to the right, we say is negative. These are linear relationship. If we have a line that is horizontal, we say that that is a zero slope. And if we have a line that's vertical, we say this line is undefined. So these are our linear relationship when we come to lines on a particular coordinate grid. We want to know that when a linear relationship is proportional, when a linear relationship, guys, is proportional, that means through, and let me show you two ways, and I definitely want you to understand this two ways. We can look at it from the standpoint of a graph, and that just means that if that line is going through, that line is going to go through the origin. Going through the origin gives us a y-intercept. And that's all that means, that gives us a y-intercept of 0, 0. Now we've talked about the y-intercept. We know the y-intercept is when x is 0, then the y value is some particular number. So here 0, 0 will give us our particular y-intercept. Now the author made mention here when he's talking about this particular constant of proportionality, when we have these proportional relationship, it says if you write this as y equals mx plus b, then what you're saying is y is equal to mx plus 0. So keep that in mind, that when you're looking at a proportional relationship, or if you're trying to determine a graph having a proportional relationship, then the y-intercept runs through the origin of the graph. Also, if you see here, the author says we can write this in the form of k equals, well, I'm sorry, he didn't, I'm getting a little bit ahead of you. he says we can write this as y is equal to k times x. So if y is equal to k times x, we call this a direct variation. Direct variation. Y varies directly in accordance to x. That's exactly what this is. If we don't have a b there, y equals kx, and we call k the constant of proportionality. This is what we call k. And we can find k by just putting k is equal to y divided by x. And if that seems familiar to you, yep, it's the same thing as finding m, which is slope. Okay, so let's see, can I get rid of some of this clutter? Hopefully. Let's see. Oh, well, I might have pulled it in there permanently. Anyway, let's move on. We want to take a look at graphing unit rates from various representation, and this is what we'll do in the next video. I don't want to run too much over this one. We want to look at graphing from verbal standpoint, which is some particular words. We want to look at a numeric standpoint. We want to look at from a table standpoint and from an algebraic standpoint. So stay tuned. This is Mr. Taylor, and I'll see you soon.